Alright, so grade 11. We are going to look at Newton's laws. We are going to look at 4 laws of Newton. Yes. Where is yours? Why is it not here? Your flip file. Why is your flip file not here?
Because the chapter 1 I just put it in my book.
Did you see we are close to finishing? Did you think I'm going to give you off the whole period? What did you think? Anyone else? Alright. So, it's a pleasure, Bukamuso. Okay, so we're going to look at 4 laws. Now, if you Google or YouTube these laws, or if you go to university, there are some deviances, meaning there's some errors in his laws, but we haven't applied it to our work in school. When you get to university and you dig into the laws, you'll see there's a bit of, not mistakes, but areas where they do not work. But in school, these laws are like golden laws. You do not touch them. All right. Now, before we get to the laws, we must first look at a few topic concepts, definitions. What's bothering you? The thing that turns. It turns due to light. So light has quanta particles or photons that goes on the white, and then the electrons jump from the white to the black and it turns it. So if you put it in outside of the light, it stops to turn, and you put it in the light, it turns. We're going to discuss that in grade 12. Alright, so first page is some things that we've done in the previous chapter. We looked at the effects of forces. What effects does a force have? A force is a push or a pull that can change the state of motion, meaning the thing was stationary, now it's moving. It was moving, now it's moving faster. So change the state of motion or deform an object. If you if you hit someone, you deform their face. Okay, so you deform the shape of the object. Then a force is a vector, meaning it has size or magnitude and direction, and it's measured in newtons. Alright. That is literally what you did in grade 9 with forces. Grade 9, yes. Okay, then the first force that we're going to look at is the normal force. Now, we've spoken about normal force before in the previous chapter. The symbol for normal force is Fn, or you can just use a capital N like that. So if you have extra classes somewhere else or look at past papers or whatever, they either use Fn or just a capital N. You can use anyone. Okay, the definition there for a normal force. Normal force is a force or a component of a force that a surface exerts on an object that is in contact with it and is perpendicular to the surface. So normal force, there's 2 things. The surface must be in contact with the object and it's perpendicular, the force. Okay, and we spoke about that in the previous chapter. We said, alright, if you have a surface there and the object is on the surface, then the surface will exert a force perpendicular to the object on it. So it's perpendicular, the normal force. Always said if we are at an inclined plane, like that, then there's a normal force that's perpendicular to the surface. So not towards the center of the earth, to the surface that is touching the object. If something is hanging on a string or on a rope, there's no normal force. Right. The next force that we are going to look at there is frictional force. Frictional force. Yes. Yes, you're writing now, June and November. Next year, March, June, September, November. So you'll write on this chapter 7 times in your high school career. So by the time you get to end exam matric, you've written about it 6 times. So do you think this is a chapter that you can just scan and like maybe study it? No. In grade 11, it counts about 30-40% of your paper 1. So this is a very important chapter. So you must make sure you understand. You do not miss a class. We're going to do a practical on this chapter. Alright, frictional force. The symbol for frictional force is a lowercase f, so not a capital F, a lowercase f. So we have frictional force, and then it has 2 subheadings. Okay, so frictional force, generally, what is it? Frictional force is a force acting against the movement of an object, preventing it from moving or causing it to move slower, and it works parallel to the surface. So if they just ask, give the definition for frictional force, this is what you're going to give. Then we have 2 different types of frictional force. We have static frictional force, and we have kinetic frictional force. Okay. Static frictional force, the symbol for that is Fs. And static means stationary. So the definition there is the force counteracting, preventing, working against, doing the opposite, counteracting the tendency of motion. So the object is not moving, it wants to move, but it's opposing that wanting to move. The tendency of motion from a stationary object relative to the surface. Okay, now the formula to calculate that is Fs maximum is, and then there's this weird looking US business, and then an Fn. Okay, now last year you did this U thing, but you did it in a different context. You did like micrometers or microseconds. Here it does not mean micro. Here that weird looking U means the static frictional coefficient, or the coefficient of friction. Okay, now the coefficient of friction is actually a ratio between the force and the normal force. And that formula there is on your data sheet, that fraction formula. Okay, now frictional force is measured in newtons. Normal force is measured in newtons. So it's newtons divided by newtons. So the coefficient actually has no unit. It's not measured in kilograms or seconds or anything like that. It's just like a value. It's just a ratio. So this is actually just a ratio because it has no unit. And this ratio must always be smaller than 1. So you'll get an answer, for example, like 0.75. If you get anything bigger than 1, you know you've done something wrong. Okay. So can you see that frictional force, static frictional force, is proportional to normal force? Proportional means if the one gets bigger, the other one gets bigger. If the one gets smaller, the other one gets smaller. Okay? And you can think, like it should make sense to you. If I have this here, and I put the eraser here, right, there will be a certain type of frictional force. But if I put the pencil case here, there will be a bigger frictional force. Yes, because the normal force onto this pencil case is a lot bigger than the normal force on this eraser. Yeah? Okay. Then why do they speak about maximum? Where does the maximum come in? I want you to stand closer, please. Come closer, stand closer. Alright. So, alright. So this here is a weight. That on this cup. This here is scale, but there's a specific name. Now I can't think of the English name. Like a full scale, but it has a different name. Anyway, but you can see, and it's not accurate at all. Just want to show you something. But you can see it gives you in newtons and in grams. And people use it like when they catch fish or when they hunt or whatever, then they hang their catch here and then measures how much. Okay. Right, now this is quite heavy. It is 5 kilograms right here. So if I pull this, you can see it shows with how much I pull. Okay, the force with which I'm pulling. But this thing is not moving. Okay, why is it not moving? One, because it's heavy. And two, because if you hear, there's friction. You can actually hear the friction. So there's static friction preventing this from moving. Okay? Now I can put it, okay, there's a 0. I can put it a little bit, and then the newtons gets bigger, and as I pull it more, the newton gets more. Right? But this is still not moving. So it means if I pull it like this, the static friction is 4 newtons that way. If I pull it like this, the static friction is 8 newtons that way. So the static friction depends with how much I pull this with. Okay, now what I want you to see, so I'm going to pull it until it moves. When it moves, so let's say we get to 8, and then when it moves, it's going to go back to 6. Okay, so I'm going to pull it, pull. Oops, where is it? Okay, I'm going to show you again. You see it become place? Okay, so that means at a certain point, just before it moves, the static friction is at a maximum. And then after it has moved, the kinetic is moving, the kinetic friction is actually less than the static friction is. Sure? The static friction becomes the maximum just before it moves. Right, you can sit down. Okay, so we spoke about kinetic frictional force. Here is the formula for kinetic frictional force. Also on your data sheet, looks very similar to static. The only thing that changes, instead of an S, you have a K for kinetic. S is for static. What is kinetic frictional force? It's the force counteracting the movement. So not the tendency to move, because kinetic, it's already moving. So it's counteracting movement, slowing it down relative to the surface. And again, there you see the coefficient of friction, smaller than 1, 0, blah, blah. Okay, so it says there, if a force F, which is exerted parallel to the surface of an object, does not move the object, then F is equal in size to the static frictional force. Ma'am, you read something, I just hear you speak, I don't know what you mean. There's our block. Our cup with our weight on it. A person sitting still. Your big school bag on the ground. Whatever. Right? And you apply a force on the object. So it's FA for applied force. FA stands for applied force. So if you apply a force and the object is not moving, then there must be static friction in the opposite direction. And if the object is not moving, then it means this one must be equal to that one. Okay, that is what that first bullet point is saying. It says, if there's a force that is parallel to the surface, so this one is parallel to that one, and the object is not moving, then F must be equal in size to the static frictional force. Alright, then they say the static friction force is a maximum just before it starts to move. That's what I've just showed you. Just before it moves, it's very high. And when the object moves, sorry, let's highlight. If parallel to surface, not moving the object, F equal to static frictional force. Remember, this is not a coloring book, ne? If you'll highlight the whole sentence, might as well just leave it. Then, static friction is a maximum just before the object moves. Then it's the greatest value. Yes. If there's no friction, if there's a frictionless surface, there's no static friction. Okay, and then when the object moves, there's kinetic frictional force, and that is smaller than the static frictional force. Okay, so you observed how the spring became less. Then, a very important bullet, and they love to ask this question for like 2-mark theory question at the end of the question. The coefficient only depends when the type of material of the surface change, not when the angle changes. Okay, so if we look at your school shoes, you all have different school shoes, and you all bought them at a different time. Some of you, your feet has not grown since grade 8, so you have the same shoes as grade 8. And some have grown, or you've used your shoes a lot, or whatever. So all of you, if you look at the bottom of your shoe, it will be different than the person next to you. Okay, because the grip on the shoe is different, right? So you will all experience different friction, different resistance, different grip when you walk. When we have like a very slippery surface, some of you will be fine walking over it, and some of you will be like, whoa, this is slippery because your grip is a bit off, right? So if the type of material changes, if your grip changes, then the friction changes, or the coefficient changes. But if we have if we have plastic and eraser here, and we have plastic and eraser here, the coefficient is exactly the same. Just because our angle changed did not mean our coefficient changed. Our friction changed because the normal force changes, but the coefficient does not change. But as soon as I swap this for paper, now the coefficient changes again because the grip. Are you with me? Because they love to ask us for like 2-mark theory question. Now you were at a horizontal plane, and now you change it to an inclined plane, like that. But you still have the same block, you still have the same type of material, wood, glass, whatever. Did the coefficient change? No, it did not change because the type of material is still the same. Yes. All right. Oh, I opened it. Yes. The pen, then it changes. All right. Sorry. Now what I want to practice is drawing free body diagrams, because this you are going to draw a lot, and this is like easily normally 3 to 6 marks in a question paper that you should get. So this here is called a force diagram. Force diagram because I show you the object. When I ask for a free body diagram, it means free of the body. So if the situation is about a block, then you're not going to draw the block anymore, you're just going to draw a dot. If the situation is about a house, you're not going to draw the house, you're just going to draw a dot. Okay, so free body means free of the body. So we are just going to draw a dot here. And now we're going to look at all the forces acting on this object. We always have gravity towards the center of the earth. Okay, Fg is gravitational force. You'll see some other schools, textbooks, whatever. Instead of Fg, they use W for weight. It's the same thing. So Fg, W, same. Yes? But there's only one down. But yes, you can, but here, no. Alright, then you see there, well, I know there's a gap there, but it's resting on a surface. So there is normal force perpendicular to the surface. Those was like, you must hear my irritating voice in your mind. Gravity towards the center of the earth. Normal force perpendicular to the surface. Yes? Then you see here we have an applied force F. So the force is pulling it to the right. And then you see there's static frictional force to the left. Okay. Now, so that's called the free body diagram. You will need in this chapter at least 2 highlighters. 2 color highlighters. Okay? You on from now on, my saying in my class, my second saying, my first saying is what? Scientists are lazy but effective. Secondly, second saying is you are in my class, you are special. Alright? So you are not going to do the bare minimum. You are going to go extra and beyond for extra and beyond marks. Okay? So you're not going to leave this. If they ask for a free body diagram in a test or exam, you will get your 4 marks. But you are special, because you're in my class. Not special like a bit retarded, like special. Okay? And you are going to take your 2 highlighters, and you're going to highlight the vectors that are in the same plane, meaning up, down, left, right. Okay? So these 2 are on the same plane. So I highlight them the same color. And these 2 are in the same plane. So I highlight them the same color. Okay, let's practice another one. Oh, sorry. Another thing that I wanted to say here. It's not something you have to do always. But they say here the object is stationary. Stationary meaning at rest. It means it's in equilibrium. It's meaning it's not moving. So if I have these 2 forces and the object is not moving up or not moving down, then it means these 2 forces must be equal in size. And again, this object is at rest. It's not moving to the right. It's not moving to the left. So it means these 2 must be equal in size. Do you still use these symbols in mathematics? Okay, sharp. Right, next one, they say there, an object pushed against friction at a constant velocity. Okay, so again you see the same scenario. So we have, and where am I with my question? Lucidi, give me one of the forces acting on the object. And you're not just going to say gravity, you're going to say? Thank you very much. Relay, another force? Surface. Right, and then you see there's a force to the right, the applied force, and then you see there's kinetic friction to the left. Okay, again you're going to take your highlighters because you are special. And you're going to highlight the forces that are in the same plane. It might feel like futile to you now, like, why are we doing this, ma'am? But believe me, when we get to the difficult questions, you will be happy. Did your parents complain that you must buy highlighters? And did you tell them you use them a lot?
Yes.
You said no because you use my highlighters. Your sister has highlighters, lots. Was it on the list of things you must buy? There's a 1, your parent. It says 1. 1 packet? Oh, shame. Sorry, I meant 1 packet I've highlighted. Sorry. Alright. Sorry? Your parents? The scientific calculator? Alright. Okay. Again, the object is not moving up or down, so it means the up must be equal to the down. And now, you won't understand it just yet, but we'll explain it later, is even though it's moving, it's being pushed against friction at a constant velocity. The fact that it says constant velocity means it's not going faster, it's not going slow, it's just cruising along. So it means the right and the left must be equal to one another. They do not cancel each other out, they're just the same size. If this one was bigger than that one, then the object would accelerate forward. It would go faster, 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 faster. But it's not. It's just going at a constant velocity. Alright, and there we have something's pulled against friction. It's being pulled up. They don't say at a constant velocity or what, so we're going to ignore that for the moment. Let's draw a free body diagram. Retabile. Give me a force. Towards the center of the earth. Neakalo. Nosy. You didn't tell me there's an easier name. Grade 10. Say again? Another force? Okay, and the direction? To the... Alright. Grade 10s, 12s, 11s. I told you there will be a speed test tomorrow. Your speed test will be on these 4 definitions. Normal force, frictional force, static, kinetic. I'm going to ask 2. I'm going to ask 2 definitions, 2 of the 4. I'm going to ask.